Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I'm part of the Developer Relations organization here at Oracle. And today we are excited to show you via live demos how to create a super intelligent version of your current RAG application by integrating LangChain and Oracle AI database for agentic workflows. I'd also like to note that we are recording the webinar and you'll receive the replay via the same email that you registered with after the event concludes. If you have any questions, we have enabled the Q&A section of the Zoom and we'll answer throughout the hour as well as leave some time at the end for any remaining open questions. So today's webinar will be presented by Nacho Martinez, Data Scientist Advocate. So without further ado, Nacho, over to you to take it away.
Thank you. Thank you everyone for coming. I wanted to have this 1 hour session to kind of like answer any questions that you might have about Oracle AI database as a whole. And I'm gonna guide you through a project that I've built, that we have built with one of the libraries that I'm gonna show you today, which is langchain-oracledb, which is a langchain integration with the Oracle AI database and Oracle free container database instances. So for those of you who are not very up to date on the Oracle products and offerings, we have this package and we have a free container instance for our database, which is completely free to use with Docker or Podman or any other type of container inferencing framework, which is going to allow us to do all the testing, all the environment setup and everything automatically on a dev environment, so we can vibe code and do things with the database without having to even set up an OCI account. So I'm going to show you, well, first of all, I want to go through what this library has offered me and the kind of advantages of using this library versus not using it. And then after we go through all the advantages and disadvantages of this specific library, I'm going to show you how to basically use it in a production environment. So I'm going to go through one of my implementations of a project in which I'm using this library. And hopefully that gives you a better idea of how I integrated all of the necessary components to build an agentic RAG application. So let's get started. So the idea of this library is to basically bridge the gap between all the components that you need to build in order to create a RAG application. So RAG, when we talk about RAG, we talk about retrieval augmented generations, right? Basically, we want to have our large language models and be able to communicate with them in natural language, of course. But some of the times, most of these models are trained on all the publicly available data on the internet, right? And so that uses the whole picture, the whole, however many tens of millions of gigabytes of publicly available data. And especially the models that have been trained lately, right? The problem is that whenever we get a new document, a new source of information, that information is never actually included into the models because they have been trained up to a date, right? They have like a cutoff time of the data. So in order to incorporate like new data, new PDFs, if you wanted to talk to your own PDF documents, documents, like anything that you have tangibly on your environment, the LLM doesn't have access to that information on the spot, right? So retrieval augmented generations is a technique that can be used so that this large language model has access to it. So we do that by, first of all, I mean, we will go through the whole process, but just to let you know, there are like 4 components of this application that are important. The vector store, because we will be using vectors to manipulate our data, create vectors from it. And then from these vectors, we will create the embeddings, which are basically the numerical representations of the meaning of those vectors. We have text splitting technology and mechanisms which allow us to do chunking on the documents, as there are lots of different chunks on big files, because otherwise you cannot save everything on the same vector. Otherwise, having a vector with less data makes it more unique and lets us do similarity search or calculating the vector distance more efficiently. And it also has this doc loader function, which automatically lets you upload any type of document with more than 90 types of documents, like PPTs, Microsoft Word documents, Markdown, PDFs. Any kind of data is already automatically integrated through this LangChain OracleDB, so you can automatically upload them to the Oracle database to perform similarity search in that sense, if you're interested. So we're also going to use another feature of the database, which is in database embeddings. This is one of the features of Oracle database, and that allows you to automatically load ONX models into the database and then use them from the database. So you don't have to call any external embeddings and services to perform similarity search and create embeddings. And this model, the Mini LM one, is famous for creating 384 dimensions, which means that the dimensions for each embedding are going to be vectors of 1 row and 384 columns. There are 3 integrated distance strategies, which we will see the difference later, and also 3 search modes, which hybrid search, by the way, if you haven't ever heard of that, it's just like a combination of doing keyword search plus semantic. So how does this package specifically help us bridge the gap on it? Hold on. Let me answer this question first, because I think it's interesting. 384 embedded dimensions means that the values used to represent the meaning of a text, and we will see about this later on, it will use 384 different 32 floating point values. So basically 32 decimal different values to hold the values of the meaning of the words. And then these meanings are represented in 384 different dimensions. So we can calculate the distance between 2 words. For instance, the king and the queen will be very close on one of the dimensions, which represents like power and all these things. And then it will be very different on the gender dimension, specifically, right? So that is a way for us to have like 384 types of characteristics on all the vocabulary in English. And then all the words in the English language will be able to be represented in 384 dimensions, so that closer words in meaning will be closer on the 384 dimensional space. I know it's hard to think about 384 dimensions, but it's just like thinking about 3 dimensions, but then just having more. And yeah, this is what I mean by 384 different embedding on the embedding space. I wanted to talk to you about what a kind of workflow would look like when using the LangChain OracleDB package, right? So imagine that you have, a way to load documents, right? Let's say we use the Oracle doc loader function here, and then we load the function. We already have the document, and then we can use and manipulate it. So for instance, after having the doc loader, we can go ahead and split the document into chunks of the same length, and then those will be used as vectors in the database. So for instance, if I'm using a 100-page document or a very long document with a lot of information, I want to be able to split the document into groups of data so that whenever I'm asking a question, I don't actually perform similarity search on the whole document. I just want a part of the document that is relevant enough to answer my question. That is the idea of text splitting. And this has already some strategies that don't usually appear on, when you're not using LangChain and this package. So for instance, one of the techniques that people do and perform with text splitting is actually having some overlap at the beginning and at the end of the chunk to preserve a little bit more context. So for instance, if I'm just doing let's say that we have this strategy for splitting that basically does text splitting every sentence, right? But imagine that an answer requires more than one sentence to answer. Well, then we might lose half of the power of our chunk that we created. Our split text will be half the answer. So for some of these models, they do have 10% overlap at the beginning of the chunk and then 10% at the end as well to try to remediate that a little bit. And then after having the text chunks, right, we can create embeddings from them. We can vectorize them first, and then we can create embeddings from these vectors. So all of the vectors will end up having 384 dimensions, right? This is part one of what the langchain-oracledb package offers. I want to talk about the Oracle VS part, which is the second part. We've also only talked about doc loading, text splitting, and embedding. So Oracle VS is part two, and is my favorite part because it abstracts the creation of all the vector tables, the vector retrieval, the indexes as well, HNSW or IVF. So it's just a way for if you know about machine learning, IVF would be closest to having centroid tables and doing k closest neighbors or k nearest neighbors, like k and n. And then HNSW is particularly useful for when you have millions and millions of rows on one table. So creating an HNSW index, especially for embeddings, is very useful when you have a lot of data. In database ONX runtime, as we said. And then when we actually talk with the LLM, we're going to see this part as well about hybrid search retrieval, which combines keyword search retrieval and semantic search. So semantic search or similarity search will actually use the Oracle VS package as well to perform the similarity search. And both combined will actually produce a combined vector similarity score or a search score. And then this will it uses our re-ranker as well to re-rank all the results. And then this will give you the actual best information that you have already on your RAG system, right? These were the four main things: Oracle VS, the embeddings part with no external API calls. By the way, you're doing every operation in database. The text splitter by either doing chars, words, sentences, with or without normalization, and the doc loader functionality, right? So this is kind of how you would use this package, right? With the langchain-oracledb embeddings. And of course, I mean, before I go any further, let me show you that all of what I'm talking about is on this repository, which I welcome you check it out. And please, if you like the content, we are making significant strides towards improving the content in this repo and keeping it up to date. We have a lot of applications like this one, which we talk about today, about Agentic RAG. We have ready to use standalone notebooks, so you can test this yourself with Oracle AI database. A lot of integrations on file systems, databases, the usage of Oracle VS in many of them, which is very, very helpful. And also guides for all the presentations that we do. And hopefully in the future, a lot of workshops as well. So please check out the Oracle AI Developer Hub. Everything that I'm talking about is on the apps directory. This application is the one that we're going to talk about today, right? And this is going to use the vector embedding store for Oracle AI database, which I'll come back later. So this is how you would load an ONNX model. And then this is how you can create an instance, which of course runs in database. So you just need to provide the specific model that you want to perform the embeddings with, which would be typically the mini LM one in this case. And then as you see, this is a 1 row and 384 dimension values between -1 and +1 that basically represent the meaning of hello world, right? So what about vector store? In vector source, you get to use this Oracle VS abstraction that essentially abstracts all the complexity away. So you can already use cosine strategies, Euclidean distance, etc., and then retrieve the nearest results. You might say, how many vectors should I retrieve when I'm asking something? Well, depends on the amount of your data. If you have millions and millions of rows, you might want to increase this number, but the less data you have on your system, the less relevant vectors there will be. So also think about that when thinking about a similarity search strategy, right? Yes, it does do chat completions. If you can also use the GenAI service models. So if you, I think this is relevant to talk about, especially for developers and software engineers. All the AI models like on Oracle AI database, they are OpenAI API compatible. So you can either use your own local models, like for instance, like doing your own inferencing through open source, or you can use the GenAI service. And both of them support the OpenAI API specification. So you can generate an API key with the OpenAI spec, as well as an endpoint, and then make completions to that endpoint plus API request combination. And yeah, we do support, for your information, a lot of Google models like Google Flash Pro, like Gemini, meta models, and XAI models like Grok 3, Grok 4, etc. So if you wanted to use these models in database, there is the possibility to communicate naturally with the models and with the data in your database using these models through something called instance principles, OCI instance principles, if you are interested in that. What distance strategy do you recommend? We're going to see, I believe, here. Yes, it's the next slide, Joseph. So bear with me. There are 3 types of distance strategies, and they are, typically it depends on the amount of, on the ranges of the results that you want, right? So cosine similarity distance, and, sine, cosine, all these non-linear mathematical equations, they tend to normalize the data between some ranges. So in this case, all of the data, however many values you have, they're all going to be, after performing distance strategy with cosine, they're going to be in the range of 0 and 2, which means that, cosine similarity is typically used for text matching because it's all the results, however different they are on the embedding space, they will produce a value on the distance between the 2 vectors of 0 and 2. It has its advantages and disadvantages. For me, I've used either the cosine or the Euclidean distance. The Euclidean is basically the absolute natural number distance, which is always higher than 0, but it has an infinite amount of, how do I say this? It's infinitely more different than when you're performing cosine distance because you can increase the magnitude of the differences. And the same goes with dot product, but you can increase the magnitude of the difference between two vectors both negatively and positively. So you can also make the distinction how different, how linearly different two vectors are positively and negatively. As you know, if you use Euclidean distance, you will have to think about just like kind of like a magnitude or absolute value of the distance of the two values, but there is only one order of magnitude or one dimension of the magnitude. With dot product distance, you can have both of them. What about the metadata now? I wanted to talk about very briefly about the metadata because if you want to perform hybrid search, the metadata of these documents is typically something that you want to keep. And someone asked already, this is one of the advantages of using the Oracle doc loader rather than using the standard text splitter and then embedder, right? You get automatically generated or preserved metadata columns. So you can use these to perform hybrid search as well afterwards, right? As you know, if you were doing like text splitting, you would be, doing all the splitting yourself. And, it will have much more, you will have much more granularity and control of the outputs. This runs inside the database, and on the other side, the direct in-database loading will run directly on the database and will do everything for you. So it depends on what your workflow is going to be. Is it going to be more retrieval focused, or is it going to be more, keyword search or hybrid searching on that data? So this is the flow that we saw. First of all, we need loading, splitting, embedding, creating the embeddings, storing these embeddings on Oracle VS stores, vector stores, with vector columns on SQL, and then we can perform similarity search on it. As you see, the whole workflow from data ingestion to data processing to then allowing this data to the user is all contained within the same pipeline with langchain-oracledb. And this is about, I just wanted to mention about hybrid search, but the usual workflow would be like, okay, I have a user question, right? And I want to perform hybrid search. So I will perform simultaneously keyword search on my vectors, but as well as semantic search, typically on the metadata or on the embedding, right? And then you will, have two different values of the scores, and then a re-ranker, which is typically called a re-ranker or a ranker, will rank the results and decide which one is best. And then based on those results, it will build a combined response using the keyword results and the semantic search in a kind of like mixture of experts or ensemble models. And this is how you perform hybrid search. Very easy. You just have to specify an index name for it, and then you will have it, associated to a specific vector store. So this vector store will have this index, and then you can select the search mode automatically. So you can then perform, queries here. So yeah, this system, the idea of this system is I'm going to talk to you about Agentic RAG, which is the implementation that I did with the langchain-oracledb package. So you can see how this actually is able to be used on a production system. And on this system, we will have 4 types of data ingestion pipelines. So as you'll see, depending on the source, I will, have to run this pipeline. Where is this? I will have to run this 5-step pipeline for each type of data type. So for instance, I'm allowing through this package, which you will see, and of course you have this here on, you have all the source code so you can run this yourself. But this is going to be a way for you to perform RAG against your documents with different types of data, either through PDF, like processing websites, kind of like web search, GitHub repositories, as well as having a general knowledge base which encompasses the three of them. So the idea of having traditional RAG is like step one, right? But it's not enough to just like say, let's give a large language model a system and then connect it to RAG, like an LLM connecting it to RAG, because it has no planning, no reasoning, apart from the original reasoning of the large language model. But it's missing a little bit of this agent harness where large language models are able to communicate between themselves, arrive at conclusions, judge responses, make critiques, and everything together collaboratively, right? So I wanted to combine the RAG system with some actual intelligence that we can give to the application. So this is what the Agentic RAG project does, right? Has multi-step planning. So all you have kind of different workflows for your application, for your data. So rather than just like answering the query with RAG, through, of course, like doing embeddings, then doing similarity search, and then returning the results, there is no LLM connectivity. You just get the result and that's it. But I'm adding some layers on top of that. I'm adding an intelligence layer, a memory layer, and some multi-step planning workflows, deep reasoning with some reasoning strategies, which you might enjoy. But let me go through this first. Yeah, let me show you here. So this is kind of the idea of the agentic RAG, right? We have talked about document ingestion until now, either with PDFs, and this is what I wanted to tell you. I forgot. I think it was you, Lalit. The way in which I'm processing PDFs, I'm doing through Docling. Docling is an open source library which I really like. Has all the extraction capabilities that you need from a PDF, as well as images. But then you need to go through their documentation and then integrate with Docling, which is basically a PDF processor that is also allows you to extract text from images and create all of the embeddings correctly, and all that you need to actually perform similarity search on the PDF. So how does it do it? Through OCR. So optical character recognition systems will run a query against that image and then get that specific text from the image. So you can create additional vectors that people that only process text don't usually get. For web, I'm using Trafilatura, which is another open source project that allows you to basically extract all the text from an HTML website. So you just pass a URL like a Wikipedia or something that doesn't have a paywall, and then it will extract the text. So you can then perform text splitting on top of it, as well as code as well with a third type of open source open source repository called Git-ingest, which allows you to convert from a Git repository to Markdown, and then doing all the splitting and the embeddings and the vector storing on that Markdown itself. That is the idea. By synthesizing, I'm actually talking about LLM synthesizing. So let me explain. After we have gone and put all our documents into our database, and then they are ready to be used through similarity search, through indexes, etc., I have this kind of intelligence layer, which I call agent chain of thought, but actually there are more workflows like this, where I am invoking 4 different types of personalities for the LLM. So basically, I'm instantiating 4 instances of my large language model which in this case uses Olama, which is open source, an open source inferencing framework. So you can use Gemma 3. I mean, I'll show you right here, right now. You can use, so for instance, you can have a lot of Olama models downloaded on it, like Qwen 3.5, the 35 billion parameter, which by the way takes about 23 gigabytes of VRAM. So this is at the limit of what an A10 would allow you to run. This released like 3 days ago or 4 days ago. Qwen 3 models as well, Pi 3, Gemma 3, which is very lightweight, and I really like it. So I mean, you can use any Olama model here, right? And depending on the amount of RAM that you have. Then you can process the documents, right? Either a URL, a PDF, etc. And then use this, I was just saying hello, but you can use the chat interfaces then to communicate with this model. So whenever you make a request, right, on the model, this workflow, where was this? This workflow launches where you have a planner, which is an agent, an LLM agent instantiated with that Olama model, which will act as the planner of the system, which will draw a set of steps for the researcher, the reasoner, and the synthesizer to perform. The researcher has automatic access to vector stores, so it will be the agent, the LLM agent that does the vector similarity search and re-ranking and everything against whatever you have already on your data. Then the reasoner will interpret the results and combine the LLM thoughts from the planner with the vectors. And then the synthesizer will take all the output from the reasoner and make it basically essentially make a summary for the user. And then we, through Gradio in this case, but also I'm experimenting with OpenWeb UI, which is very popular as well as a front end. It will allow you, first of all, it will, the researcher retrieves the vectors, then the orchestrator, which is like the boss, you're considering like making sure that everything runs correctly. And then the synthesizer will compile the final response. This is relevant because I was just doing a test, but if you actually use a reasoning chat, which this has more reasoning strategies, and I really recommend you try this because I could be talking about this for hours and hours, and I wouldn't have enough time to talk about all the functionalities. You can use RAG plus reasoning strategies as well. So we've talked about chain of thought. We have never talked about tree of thoughts. The tree of thought reasoning pattern is chain of thought, but like doing that in parallel, you can have self-reflection, which allows the model to reflect upon what it just generated before answering you. And all these reasoning strategies actually improve the reasoning quality a lot. So for instance, I created this instance where I was asking the model about what was my question. Can I see? Was it like, what is YOLO? Which is like you only look once. It's a vision model, and which I previously uploaded a document for it on the document processing tab. So let me show you how the processing looks. But the idea is that in the execution trace, we'll be able to see the planner talking, it's gonna start with 2 different strategies because we selected chain of thought and self-consistency. It will retrieve the relevant context from the PDF collection. It got 5 relevant chunks because I just specified k equals 5. I launched the strategies in parallel, and then the models actually answered for each of them, and then a cluster or a mixture of experts decided that the chain of thought response was better. And this is the whole reasoning, right? First of all, you need to understand the question, analyze the context for information, construct the definition of YOLO before answering anything to the user, right? And then actually producing the final answer. And also, if you have metadata, like I said, this is the PDF that I uploaded, you can trace back whatever vectors you used on your response. You can trace them back to the user saying like, oh, this is, this appears on paragraph 53 on page 7, kind of something like that, right? And this is the idea, right? By the way, and this is just a way for you to visualize whatever is happening on the system. So I just built this live system monitor to complement the front end. So you can also score and log all the events, and they are automatically added to Oracle database on logging tables. So you can then go back and actually see the specific inputs and whatever each specific agent is running and outputting through A2A. So A2A, I would like to talk about this so much longer. A2A is a way for agents to communicate between themselves and make them independently and scalable. So it's very like Kubernetes and Docker friendly. Show you one more thing that I wanted to show you. This is kind of the workflow, and of course, you do have all these slides on the chat, so please check them out. There are a lot of slides. So if you're interested in this, please check them out. But let me just talk about agent to agent for a few minutes, and then we'll be done. Agent to agent is a protocol that was developed by Google. Shout out to Holt Skinner, which is the developer advocate and the maintainer for the A2A protocol. And he was able to give me a bit of information when I was implementing this about the advantages and disadvantages of A2A. It's just a way to allow all your agents to be deployed autonomously and on different computes if you wanted. So I could have my planner agents on one server, my researcher agents on another, and all of these things would be automated for me so that through the A2A protocol, I can synchronize them to produce responses regardless of if they are in the same compute or not. And this is the workflow, right? First of all, you have the planner, and then the researcher goes into the database, queries the PDF collection, the web collection, the repository collection, whichever vector store you're using in the Oracle database, and then it will go back, reason, and synthesize, and produce the final response. So depending on which, I do recommend that you check out the Trafilatura, Dockling, and Git ingest. They have Python bindings for those of you who are Python developers like me. So you can use them in combination with the langchain-oracledb package. And these are the reasoning strategies that are implemented. I've done a lot of things about benchmarking these reasoning techniques. All of this is on the Oracle AI Developer Hub. So please, if you have enjoyed this session, please go to GitHub and start this project. Just click on here and start the project because it helps us a lot with visibility and everything. And please check out the notebooks. I also have this notebook here, which uses Oracle VA's embeddings text splitter. Just try it yourself. You don't have to install or do anything. It will work automatically against your free container instance, Oracle database free container instance. It shows you how to perform all the code that we have seen on the slides. Creating the vector stores, doing hybrid search, how to connect to a database. In this case, the Oracle free. If you can either use Oracle AI database, which I'm using here, or the Oracle free container instance. How to load ONNX models in the database, and everything. So please check that out. Are the models shared with other customers? No, they are physically isolated. The model weights are on the compute, which is shared, but your specific, requests and everything are never shared with any other customers or even the creators of the model. So XAI, Gemini, anything that you use with Oracle GenAI service, they will not see that information ever. Yeah, hopefully you enjoyed that. We're gonna do more of this in the future. So just stay tuned to the socials on Oracle developers. Of course, if you're interested as well, you can find me on GitHub. I do have my portfolio here and everything. And just like connect on LinkedIn or whatever you need. We are here for that.
So thank you all for all the great questions. If you enjoyed today's session, we do want to invite you to any of our upcoming webinars. We do one pretty much every single week. And you can find all of those at oracle.com/developer/events. And I know a few people asked about the recording that will be emailed to you directly at the same email that you registered at. But if you did want to find any of our previous sessions as well, if you, on that same page, the events page, there's also a direct link to our YouTube playlist, and that's also at youtube.com/oracledevs in the developer coaching playlist. So lots of great material there to check through. And we'd also love to hear any feedback that you have for us on today's topic and on future sessions. So please, if you do want to share that feedback with us, there is going to be a quick survey that pops up as you exit the Zoom, and we'd love to hear from you. And then we also like to let you know that we are coming to a city near you in London and New York City. So March 25th for London and New York is April 10th. And Nacho and I will both be there. The rest of our team will be there in person. And we're going to be giving a 3 lab workshops. And we're going to be going from AI data fundamentals and vector search concepts to building a production style RAG pipeline and then evolving it into an agentic application with LangChain and Python. So it's going to be really interesting. It's a complimentary event, and those were the 2 links that were also included in the chat. And we'll have those linked with your replay as well. So we'd love to see you in person if you happen to be in one of those 2 areas. So with that, thank you so much for joining us here today. And we really appreciate you spending your time here with us and all of the great questions that you asked. And we hope to see you at the next one. Thank you, everybody.